Okay, good day everyone. Welcome to my YouTube channel. Now, in today's video, we'll be looking at expansion in solid. Now, what is expansion? So, expansion is the increase in the length and the size of an object. Now, when an object expands due to heat, that same object contracts when it is cooled. What do I mean? Now, let's say this is a wire, okay? Now, this wire you're seeing here is the same thing with this. Now, I'm going to explain. This is the original size and the original way of the wire. Then when this wire is being heated, it what? Expand. You can see the way it is stretched. It's just like the wire in our pool. When it is being fixed, it is a straight wire, a straight line wire. But when it is heated, it expands. But when it is cooled, it returns back to its normal way. Now, under expansion in solid, we have three factors there. What are my factors? We have the first one, linear expansivity. Linear expansivity, which is denoted as what? Alpha. We have areal expansivity. Sorry, areal expansivity, which is denoted as what? Beta. And we have the last one, volume expansivity. And this is denoted as what? Gamma. So these are the three factors when it comes to expansion in solid. You have the first one, linear expansivity, which talks about the increase in length of an object. And we have the second one, areal expansivity, talks about the surface area, and we have the volume expansivity. Now, before looking at the question under linear expansivity, the formula we make use of when solving linear expansivity is alpha equals to change in L over L1 change in theta. So most time people call this delta L. They say the same thing. So what this means is change in L equals to L2 minus L1. So now let's say there are two lengths given to you. The second length is regarded as what? L2, and the L1 is what? The first length. So people can also say it as the final length minus the initial length. So if you see it in some textbooks, in some online places, it's still the same thing. While this one here you are seeing here, it is change in temperature. Change in temperature. Like I said, some people can call it delta temperature or whatever thing. So this temperature is theta 2 minus theta 1, meaning the second temperature given or the final temperature depending on the textbook minus the initial temperature. That is the delta theta. So this one is the symbol for linear expansivity. So difference between a linear expansivity and area expansivity is that area expansivity is 2 of linear expansivity. So this is area expansivity equals to 2 times the linear expansivity. So in terms of volume, which is gamma, so your gamma is 3 of the linear expansivity. So you can still stick to the formula. This just replace your alpha with either beta, which is for area expansivity, or gamma, which is for volume expansivity. Now we can see a question under linear expansivity. Now this is the question. They said a rod of initial length 2 meters at a temperature of 25 degrees Celsius is heated to 80 degrees Celsius. Calculate the increase in length. Now when they say increase in length, they're talking about what? The change in length, which is that delta L of the rod if its linear expansivity is 4.0 times 10 raised to the power of what? Minus 3 per Kelvin. So, solution. Since they said linear expansivity, that will make use of what? Alpha, which is equal to L2 minus L1 over L1 change in temperature. So this one I can just take it as what? Delta L. So I have alpha equals to delta L equals to L1 change in temperature. So my alpha is what? This. So I have 4.0 times 10 raised to the power of what? Minus 3 equals to what? Increase in length, just change in L over L1 is what? 2 meters times change in temperature, theta 2 minus theta 1. And what is theta 2? 80. So 80 minus theta 1 is what? 25. So what do we have? We have 55. So I'll times this now by what? 55. So this will give me what? 55 times 2. That will give me 110. So I'm going to cross multiply 4.0 times 10 raised to the power of minus 3 times 110, which will give me my change in L. So my change in L will be equal to what? 0.44 meters. So if you do this in your calculator, you're likely to get the same thing. Now, so let us look at a question under the areal expansivity. So now, this is it. They said the area of a square meter is 600 millimeter square. Pay attention. Calculate its new area when its temperature is raised by 15 Kelvin. Linear expansivity equals to what? 1.9 times 10 raised to the power of what? Minus 5 per Kelvin. Now, solution. Like I said before, this is under the area expansivity. So you do beta equals to a square, a2, sorry, minus a1 over a1 change in temperature. So this A2 minus A1 is a change in area. So your A2 is what? Is it given? No. Your A1 is given as 600 millimeter square. Now, if you pay attention, you realize that our area is given to us in what? Millimeter square. Now, we ought to change it to meter square, but we're not going to change it. Do you know why? If you look at the options here, they are all in millimeter square. So it means that there is no need for us to change the unit. Let's leave it as what? Millimeter square. If it was in meter square, I would have considered changing it to meter square. So now my beta is what? Remember, beta is times 2 of the linear expansivity. So 1.9 times 10 raised to the power of minus 5 times 2 will give you what? 3.8 times 10 raised to the power of what? Minus 5. So now this is my what? Beta. So I put it here. 3.8 times 10 raised to the power of minus 5 equals, we are asked to look for the new area, which is this A2. So what do I do now? I'm going to cross multiply. So this will times this. So this A1 is giving us what? 600. And change in temperature. Remember, change in temperature equals to theta 2 minus theta 1. So is it given? Is raised by 15K. So this 15K is our change in temperature. There's no need of us doing theta 2 minus theta 1 again, because only one temperature that is given to us. And they said is what? It is raised by what? Change in temperature 15. So 600 times 15. What do we have? 15 times 6 will give you what? 0, take 3. 6 times 1, 6 plus 3, 9. So we have 9000 times this equals to A2, which is the new area, minus the old area, which is what? 600. So I'm going to times this, but before that, I'll take this one over here. So this will give me 3.8 times 10 raised to the power of minus 5 times 9000 plus 600 equals to E2. So now, if I'm to do this in my calculator, I'm going to have, it's going to give me 600.342 millimeter square, and which is what? Option D. So I'll leave you with this question. They said the length of a zinc rod at 23 degrees Celsius is 200 meters. Calculate the increase in length of the rod when its temperature rises to 33 degrees Celsius. Linear expansivity of zinc equals to 2.6 times 10 raised to the power of what? Minus 5 per Kelvin. So I want to do this and tell me your answer in the comment section. So see you in my next video. Don't forget to subscribe and turn on the notification bell to receive more videos like this.